All right, I think we're good to go. As per usual, let's do some quick housekeeping. This week we're going to be focusing on mainly PMMA and wax printing for investment casting. Unlike last week, there's not as much design work that needs to be done to get these to print correctly as they print solid. So this one is going to be less design work like that and more just post-processing more than anything. And then after that, we were kind of in a weird spot with the different materials. It was too long to do all four of these materials in one workshop. So I split up the SLA and the fused filament section and this section into their own sections. But this one's definitely a little shorter than the other section would have been. So afterwards, we're going to do a little bit of talking about it's going to be a hodgepodge thing. I'm going to show a quick video of our investment casting system. It's a robotic investment casting system. And then I've been pretty generous. I'm not generous isn't the right word, but I've been mostly just sticking to the pros of each type of material and printing process. But we're gonna talk about a lot of cons this time as well afterwards. Once again, if you have any questions, feel free to ask them throughout the presentation. And then other than that, let's get started. So 3D printed wax here. There's a couple options on the market now. I still think the most popular is probably the 3D Systems 3D wax printer. I believe it's a 2500 IC. And a lot of people like this material in general just because it matches their process already so well. You can melt it onto your wax sprues, use the same wash that you use for your regular patterns, things like that. It's all autoclavable. Yeah, it just really fits well into your existing process as is. So, one weird quirk of printing with 3D wax is when you print them, there's all just like you're going to find in fused filament, there's going to be your supports. And you can see that on the bottom right picture there. This is their 3D Systems old wax, I believe. It used to be purple. It's more green now. It's more of a lighter green, but that white stuff there is going to be your support wax. That's going to just help print overhangs and stuff like that. The big issue with that is after you've printed it, you have to break it away. And that tends to be an issue on especially small, delicate things like the rings and jewelry you see here. When you're breaking those supports away, there's a non-zero chance you're going to end up breaking your actual part. And usually, I have big hands and I'm clumsy sometimes, so I tend to break them pretty often. I'm going to pull out a little demo part, kind of showing these last week, or not the first week. This is a little test artifact we use sometimes. Am I still sure? So you can kind of get a good look of it here. It's just a little green. It's to test layer lines and stuff as you're printing. Green is the actual printed wax, and the white stuff is the support wax. And it doesn't print the support wax solid. It prints it kind of like struts. Let's see. Come on, camera. There it is. There's little like pillars of support. So they're pretty easy to break away for the most part. Breaking off a little piece here to show. But they crumble off nice like this into little individual support columns. And you're able to get most of that off that way. And that's kind of what we do. We take a lot of like clay modeling tools, things like that, to break away the supports there. However, you can't break it all away with that way. The way we usually remove these after the fact is sorry about that. One way we remove these after the fact is we have a IPA bath. That's also heated. It's a heated plate with a stirring rod. We'll take the IPA to no more than say like 40 degrees Celsius. Any more than that, and the green wax will start to deteriorate as well. You can see it start to crack and split and things like that, especially when you move it out. And then if it's too hot, also when you pull it out, it starts to rub away like normal wax, what you would expect it to. And usually, if we're going to break it apart, it's after we remove it from this wax bath, and we weren't able to control the temperature as well as we'd like. This tends to be my least favorite part of the wax. So the IPA bath, it's difficult to get it just right. And even when you think you get it right, sometimes we have students bump into it and mess up the dials, and then we gotta tweak it again to get the temperature right. It's a 10 dial slot, but it kind of has a gap in between 0 and 1 that we can set it on to kind of heat it up sometimes. It's not the best bath, but it works. Now we're gonna hop right into the wax setup. They're much easier this week, so it won't take much time. Let me pull up screen share again. We are going to 3D sprint again. So same screen as we used for the SLA printer last week. This time the printer we're using here is the 2500 IC. We're going to use their ICAST wax HD general settings. Nice thing about this guy, much easier to set up, not much settings to tweak in general. Pull in the Hobbit house, we'll place it up front like usual, and we're going to orient it normally. This is another example of a part I probably wouldn't print in wax because this little guy is going to be expensive to print solid, right? But just for demonstration purposes, oh, the Zoom meeting is in the way. There we go. Place it in the center there, and then all I would have to do, run an estimate to see how long it would take to print, how much material I'm going to use, and print the file, and it's basically good to go. One really nice thing about this is how easy it is to set up. A couple little quirks here. The placement of the parts, I think, matters a lot. We found that if you place it really close to the front where the print head is, I should talk more about the print bed. So in these wax printers, there's going to be 3 sections, and those are going to be divvied up along these dotted lines here and here. It's going to use those sections of the print heads on each part of the printer, right? So if I have it all in one zone, you can see this little like translucent box here. It's just going to print in this one zone here. But if I were to move it to where it's, oh, not spin. All right, it's going to spin a little bit. If I move it over here, this box is going to extend. It's going to have to use 2 sections of that print head to print out this part. And I think before, if I was printing in just the middle, it was taking about 2 hours. This almost double the time it takes to print that, even more, 2.5 times to print this guy. So we can shorter print time by using only 1 section of the print head if we can. It's not always possible with the parts bigger, for instance. And another thing we like to do on this printer, if we have the part really close to the front here, that's where the print heads tend to rest. It seems like the front of this bed is a little warmer than it is back here. And that can cause some warping in the parts every once in a while. So typically we'll start the print maybe halfway through, maybe a quarter back, depending on the part. If it's a really long part, we'll get as far away as we can, basically. This isn't really it's gonna add an extra hour to the print time, but if it overheats and warps, then it's gonna be another 2 hours to print. So kind of helps that issue. We haven't really seen any like print lines between printing across the different beds on the printer, like we would with the DLP printers. It's just more of a taking longer to print because it's using 2 sets of print heads instead of just 1. Not many settings to tweak in this. You can technically infill your parts. We almost have never done that. I think we might have tried it once, but we tend to just leave them solid because it's more similar to its traditionally made counterparts, right? Is there anything? The only other really important part, using these settings, there's some shrinkage settings on here. If you go to the settings button, go to, which one is it? Is it not this one? Oh, sorry. There is a shrinkage factor that you can apply. It's printer tools. That's what it is. Printer. If you go to printer settings here, this is going to add a scaling factor to your prints. So that's just to account for the shrinkage that's going to occur from the hot wax cooling down. And there's also an enhanced cooling mode as well. It's supposed to help keep the part keep it from overheating and warping. We have the build style on this computer isn't set up, but we have another imported build style that we import that has these almost exact same settings with just the enhanced cooling mode on to prevent from warping. Other than that, there's not much to talk about the software. It's pretty plug and play, not much stuff to tweak. Once again, it's more about aligning your parts to prevent supports from being in bad spots. But once again, with this part, there's going to be bad supports everywhere anyway, and there's not much you can do about it, other than try a couple different orientations. Another unfortunate thing is it doesn't show the supports. That's always kind of bugged me. But I'm not sure. Maybe they may have been, maybe a new version has support shown on the wax printers, but I haven't found anything about that yet. So any questions about wax printing? You guys are in the investment casting industry, so it's almost the same, just you're 3D printing instead of using your injection tools, right? All right. Let's move back to PMMA. Where are you, Zoom? My Zoom meeting bar is acting up today. Sorry about this, guys. All right, PMMA. I may have brought it up before, but this ends up being usually my favorite go-to 3D printed material. I understand that I'm lucky to even be able to have one because I know the upfront costs for these things are insane, but I do like working with this material a lot. So a PMMA pattern is going to be a binder jetted pattern. It's going to be made out of PMMA, so polymethyl methacrylate. It's an acrylic powder, and it's going to be glued together basically with a type of binder, proprietary binder, VoxelJet in this case. We have a VoxelJet VX1000 that we use to print all this stuff. The one thing I am unable to do, unfortunately, is I can't walk through exactly the printer operator and the slicing components of the VoxelJet, unfortunately. The issue I have there is it is an offline printer. We can't connect it to our internet because of some IT issues. And I can't get a screen recorder on there to actually capture any of the operations. And also it takes walking someone through how to start this printer for the first time can take a really long time. It's a really involved process. So that's kind of one of the big issues with the printer is it's not only is it really expensive to even be able to purchase one, but it's also really it has the biggest knowledge gate to be able to use it. But what it can do is print large print beds of a lot of patterns at once. And after the upfront cost, it tends to be a little cheaper as compared to some photoreactive resins or 3D printed wax raw cost wise, but that initial upfront cost is quite hefty. So here we can, on the right here, we have a little picture of some 3D printed patterns that are just fresh out of the box. There's the loose white powder, and there's also some support structures that it prints in there. Unlike the other support structures, these can be broken apart quite easily and filtered through the reclaim system that comes with the printer to be able to reuse the powder over and over again. You also have the ability to turn that out if on really short boxes, we tend to turn it off as it doesn't it's not as necessary as it is with some of these taller parts. Notice if we print a really tall box of PMMA patterns, after a while, it's at a certain height, probably like 100 millimeters deep or so, there'll be a shift and the parts won't align anymore. So on really tall parts, we tend to turn those back on. Another nice component, also kind of why this got grouped up with the wax printed parts, is it's autoclavable. We use flash fire still, but I've heard a lot of foundries that have used this for they do use this in their autoclave and are able to take it out no problem. So it can fit nicely in there. Post-processing wise, we'll take these parts out of the print bed. We'll move it into an air blasting cabinet. Just pressurized air and brushes to brush off any loose powder that's still attached to the patterns. We have a regular air gun to blow off into any crevices, and we also have a little tiny pressurized air nozzle that we can stick into really thin passageways and blow out any excess material there as well. Usually there isn't too big an issue removing the loose powder on really complicated turbines that have like deep fins on each of them and closed fins like the one on the right here. Those can be pretty tricky to get the powder out. We were pretty good at it. We can get it out most of the time. It's not really the powder that we have an issue getting out. Usually it ends up usually being the wax after we dip it. So after we have these transition, after we have those parts oh, I had a picture of the clean out process. Sorry. So here on the left, I'm just taking a little tree that we have, brushing all the loose powder off. After we brush off all the loose powder, we stick it into a curing oven. It's set to about 55 degrees Celsius. We'll leave it in there for about 10 minutes and it'll be fully cured. Really big part, we'll leave it in more. As soon as we take it out of the curing oven, we'll take the parts and we'll dip it into this red wax here. That's just to seal the pattern. It's a very porous material, very, very porous material. If you don't dip it in, you have some issues with your slurries. It likes to soak up the moisture from the slurry component, not the actual binder, sorry. And then if you don't wet it, or if you're doing your wetting process, if you're putting wax on there for some reason, it can absorb that as well and cause some issues with the actual pattern. So that red wax seal there just seals it up real nice, doesn't let any other liquids get inside of your patterns. And then after we dip them in the red wax, we'll pull them out, we'll let them drain. Now, one issue here is after you've let it drain a little bit, there can be a little thin layer of red wax on the outside of your pattern that didn't fully absorb into the pattern. We just have a little cheap, like $30 Menards heat gun that goes up to like 600 degrees Fahrenheit. We'll probably set it to about 400 degrees and we'll hit the pattern with that just to let the tree reabsorb all that wax, or let it run off if it's already fully absorbed. And this is where we have some issues with surface quality. One of the big issues with the PMMA patterns tends to be compared to like their SLA counterparts, their DLP counterparts, the wax parts, the surface finish is definitely a little lesser quality. It's still quite good, but some people expect, better out of your investment casting parts. That's a reason a lot of people use investment casting. So I brought a couple more demo parts today. Let's turn the cameras on. So here's a good look at what a pattern would look like coming fresh. Let me turn the blur off so you can see a little better without having to squint. So here we have a little panther that we use here for trophies, desk trophies, speakers for our AFS chapter, things like that. We printed the gate straight onto it. We usually need a vent on the tail here for the tree to connect to the actual sprue. We can also print these onto the PMMA tree as well, but it's nice white color, almost kind of a tan. Now that picture I showed you earlier, the wax was nice and bright red. Over time, our wax container has kind of lost its color, so it's more of an orange now. Yeah, it's pretty much impossible to tell the differences. Sorry. But yeah, this guy, just a tree that we're using to do some testing. Probably one of my favorite reasons for using this printer is I can make a lot of different trees for our research projects. Unlike you guys, we're in the business of making really bad castings because we want them to fail or we want to find an issue with the process. So unlike normal people, we don't design to succeed. We try to design to fail. And then I can also do really weird stuff and impractical stuff, and some would say, like this guy here. This tree, ignore the huge pouring basin on it. This doesn't actually get poured. It's just for the robot to grip it. It's a straight tube through here. We were using this guy to make ceramic bar samples for testing strength. I know a lot of people will just cut off the outside skin of the ceramic shell basically to test it. Issue with that is, it doesn't tend to be a straight line when we put it into our tensile machine. So there's usually a point where the stress is going to concentrate on the bar. We printed this guy to make a single 1 inch by 1 inch by 8 inch ceramic bar for testing our tensile machines. Issue is one of the ends usually close up before the inside is fully filled. So we're still working on that to be able to make a completely solid ceramic bar to give a more laboratory style test result. Sorry, I went on a rant there. But anyway, it allows me, this printer lets me do weird stuff like this that isn't practical to do 1 or 2 shots of in a typical foundry. So hold on, I got to remember where I was. Sorry, everyone. I'm a little spacey today. As you know, 4th of July is this week, and I'm excited for it. And one part I do like to show off because I can't do it in regular presentations but we were doing some tests with some different materials. So we printed these little Grogu's, little baby Yodas. The reason I kept this one is the surface finish is actually quite good on them. I don't know how. It's not too easy to see, sorry, but the surface finish on it wasn't as bad as I was expecting it to be. And that's because since this was an art piece, rather than re-infiltrate all the red wax on the outside of the tree, we got most of it in and left a little bit to help try to improve the surface finish. The good news is it did a pretty good job. The bad news is it's not very consistent. So it's hard to control where you're re-infiltrating that wax with a heat gun that's blasting the whole pattern with heat, So that's really all I have to say about the wax and PMMA patterns, unless anyone has any questions about the material in general. If not, I'm just going to start going on a list of some of the cons of all these materials in general, and then show you a quick video of our dipping process and a little taste of some design work that we're really going to get into next week as well. I'll give you guys a minute to pull up your type questions while I pull up some other things real quick. SolidWorks is not cooperating. Okay. Got everything ready. So mostly talked about the pros. I'm going to start getting into more of the cons now. So we're just going to go through each printer kind of the way we went in through them organically in the workshop. So your fused filament printers, they're great, they're cheap, right? The surface quality on them can be pretty bad. Uh, Large layer lines, even if you're printing really thin layer lines, um, they're going to show up on the part typically. Uh, for me, the pros always outweigh the cons on that one. If you're doing a prototype part, you might not care about your layer lines yet. Um, any other major cons? Your filaments, huge range of quality. Even the more expensive filaments can still have a lot of ash because they're made to be more sturdy and things like that, and not necessarily to have less ash after you burn them out. Um, and I found that if you don't keep your print heads really, really clean and up to date, if there's any popping or anything like that, if they get a little clogged and they don't lay as much filament as they should, there can be just even a tiny little gap in the filament can let slurry run in there, and it's a junk part then. So when we're using fused filament patterns for investment casting, we have three Elda makers. One of them has a special print head on it. It's the AA 0.4, really small nozzle. We use that one just for those parts in particular, so it doesn't clog when we're doing standard printing if we're making like parts for holding tools on our robots, things like that. So if you're using it for the purpose of actual patterns and not for other tools, I'd definitely have a separate print head or something to keep that issue from popping up. SLA, DLP, also kind of depends on the printer. Price varies quite a bit. But even your cheaper printers are probably going to be maybe 10 times as of an average FFF printer. Still not too much. Quality is usually much better. It's what kills you on this is always the resin price. And if you're using investment casting resin, it's going to be more expensive. Hopefully one day in the near future, we'll have more resins to print for, and capitalism will succeed and drive down the price as the companies start to compete each other for cheaper and cheaper resins and better quality. So easy to set up, but con wise, it's mostly just the price. And if you're in the business of printing big investment casting patterns, then you're going to have to pay a lot up front just to have a printer big enough to actually print your part. Unless you're trying to do something piecewise and glue it together after, which we have done. But even if you're really good at gluing them together, there's usually seam lines or some issues with alignment, stacking tolerancing issues, by not getting them perfectly aligned, things like that. Wax, I do actually like the wax printer. I already talked a little bit down on it today, but my biggest issue is just parts falling apart when you're trying to clean them up, and that's probably a me issue. But if you're working in a foundry, things get handled pretty roughly usually. So I know I'm not the only one who has issues with parts falling apart and breaking them on accident. And then finally, the PMMA, it has to be the most expensive upfront investment that you're going to make. But I think long term, it's probably cheaper than a lot of alternatives, just because you can print the amount you can produce is so much higher than the other competitors. Especially with the print time being pretty competitive with SLA. It's just being able to fit more in a box is great. I'm not sure if you guys are operating on the weekend, but printers can run great over the weekend. So even if the build times are a little different, usually a big box over the weekend can bridge the gap between printing speeds. There's all my con lists. I wanted to talk a little bit about our investment casting. So I like to show it because a lot of people tend to still be using, the old way, hand dipping. We have an automated cell. And then when it's down, I get to do the hand dipping. But hopefully you're looking. Why this doesn't look right. Sorry. Here we go. So here we go. We had some summer interns a couple years ago model our investment casting cell. On this base is supposed to be the robot, but when I loaded on my laptop here, it disappeared. But there's a FANUC on there. I think it's the I believe it's the 165 kilogram payload that sits on there. And there's a little hanging station up front where the robot picks it up from. We have 3 rainfall sanders where we put our stucco. Right now we're just using 2 of our slurry tanks, all silica based slurries here. Primary is this guy, backup is this guy. The third, we plan on throwing our zircon in there, but most of our castings are aluminum, and upkeeping the zircon can be quite expensive for us since we're not a production facility. The last kind of big thing we got going on in the cell is this conveyor system. This is for a different cell entirely. Let me hide this. Sorry about that. Our conveyor system, there's these orange hooks that we're hanging our patterns from. We have 5 stations on each level. Each of the 4 stations, besides the front one, has a set of fans to help dry it, as well as infrared lights to keep the pattern from cooling too much. Notice if running those fans on it, there's a higher risk of cracking it if you're cooling it too much, and so we're trying to maintain a consistent temperature using those 2 items. This thing can run entirely offline. We usually just throw the trees on there, but at the end of the day, let them run overnight, and usually when we come back, they're ready to go or almost ready to go. I have a little video. Oh, sorry, I missed a question from you. Have you tried wax dipping FF parts like you do PMMA? Would it seal it from slurry? Yes, it would. If the hole is small enough. If it's a pretty big hole, usually you'll notice it, and you can probably patch it. We use oh my gosh, for electronics, I'm completely blanking. I'm so someone's eventually going to help me out in the chat. It's use it for a soldering gun, the soldering pin, to melt like spare wax on, and then we can sand the surface to help seal it. That can help. If you were to dip it in a wax, it would probably help the layer lines too. If you're doing if your tolerances are fairly flexible, like if you're working on some art pieces and not an like an airspace part, for instance, that'd be great because you can get a really thin layer on there. It'll definitely help your layer lines. Any tiny holes, what we do to check them usually is we just have a little vat of water, dip them in there for a few seconds and pull it out and see if any reasonable amount got in. And then we'll take if there's no air bubbles coming out, we're good to go. But yeah, we can dip it in wax. We can use wax to seal it up, things like that. Let's show you so I have a quick video here that I made for a conference where is VLC? Hello, there it is. Oh, wrong cell. All right, sorry. If anyone's interested, this is a robotic torching cell for steel casting, so I can come back to that later. But here is our robotic dipping cell. Robot comes in, grabs the T-bar. One thing this tree here I was using just to make this video for, I think, Cast Expo. So I was kind of rushing it. You can see there's a bunch of issues here, namely on the pouring cup in the feet where I glued this panther to the tree. So when we didn't print this as one solid piece, we glued the panthers on because we just had a spare tree. We use sticky wax. And normally what I would do is I take like a wire brush or something just to scratch up the wax so it can hold the slurry a little bit better. I did not do that for this, and you can definitely see some of the wax there creeping through. Some people just dip it in their regular wash to get it to hold the slurry a little bit better. We do have a wash tank, but we don't use it often. And then at the top on the pouring basin here, I didn't take as much time as I should have with the heat gun, re-infiltrating all that red wax from when we dipped it to seal it. If I would have spent a little more time up there, that all would have re-infiltrated and the wax would have, or not the wax, the slurry would have stuck to the pattern much better, like you see on the Panthers down there and the rest of the sprue. All right, as we were, pick it up. It's going to lock it in. It's going to take it to our slurry tanks over here. And it's going to be even more obvious that I didn't hit the patterns with the heat gun enough here in a second when we frame cut. What am I doing? So during the actual dipping sequence, our slurry tank slowed down. We'll leave them in there. I think this robot setting was set up to about 20-second dip time. And the drain time on this was really long. It was like almost 2 minutes long. That's not typical. Usually, we have a bunch of different robot programs that adjust the drain times for more or less complicated geometries. Once again, you can the slurry is running off at the head of the pouring basin too easily. Just because I didn't do a good enough job post-processing. 2-minute drain time. We're gonna skip a little bit, so pulls out, and now it's gonna go to our rainfall sanders. Man, whoever edited this video did a great job. Those were there. Gonna sit in the rainfall sander 15-20 seconds. Let it drain off any excess stucco. And afterwards, it'll come out and throw it on one of these orange hooks, and then that conveyor will start to turn afterwards and go to the next station where it can get hit by the fan and the infrared lights. This cell was developed by Kia. All the initial programs were as well. We've tweaked them quite a bit for trying to mimic draining times, dipping times of our like in foundry operators. This is a different part of the facility. I put it in the last little bit I stuck in this section just to kind of to bridge the gap for design next week. We have a nice little. Oh, I need to share the screen again. Man, I'm dropping the ball today. This is what 4th of July will do to you. So this tree here is the follow-up by some students to this Panther here. We have a lot of summer interns this year, and we've been looking for a new AFS Hawkeye chapter trophy, basically to give away to our speakers. And they also wanted to make some keychains to take home, as well as demonstrate the investment casting process to a lot of the different schools on the college. So they took that tree. Unlike the previous version, these are about 30% of the regular size. Because of that, these gates on the bottom here, we're getting a little close to the minimum size for investment casting. It still probably would have worked, but we figure we just flip the gates to the other side here. as we can machine the back one off, for instance, and then this guy we can adjust a little bit. We're planning on cutting this off and leaving just a little bit to turn into a little hook, so you can make this into a keychain as well as a little desktop ornament. Normally I have just the pail with the vent. However, with these feet now sticking out and being at the top, we're adding some extra vents. We're going to print this guy all in one piece up here and run it through our system. This is the altered one. This is the guy we set up for simulation to see how it would fill. But let's see if I can roll it back just enough to show you some features that the robot has. Oh, it's a huge model. I'm sorry. I crashed it. It's fine. Well, I knew better because this is, instead of being a bunch of solid models, these are a bunch of scanned STLs, so the file is huge. But next week we're going to talk a little bit about the gates I had to make, the vent sizing, things like that. Is there any questions that anyone has? No one has any questions. I'm going to run I'm going to run that other video I had pulled up, just because I'm kind of proud of that robot. We built this robot entirely in home with a bunch of college and high school students with no integrator help. And it's a Monday on the 4th of July. This is as close as the fireworks as we're going to get in this workshop. So there you go.
Joshua?
Oh, yeah, what's up?
Yes, I have a question.
Yes.
Is the same question of Yesi in the chat?
Oh, sorry, I'm not seeing I only see the question from Jesse. Did you send one?
No, okay. Is the same for the dipping in the red wax? You make this process for PMMA printing, but for FADM parts,
Mm.
you try to
So,
make this dipping or
so are you asking if you should dip your FFF parts in wax to seal them, or
yeah.
um it depends. On high tolerance parts, like a turbine for aerospace, maybe not. Because the surface of it's going to be a little rough and inconsistent, where the wax is going to pull up, right? So you're going to gain your surface roughness might be a little better if you were to use like a profilometer, because it's not going to feel the ridges on the part, but there'll probably be more peaks and valleys in the wax just because it's pulling in different regions. Um, we have dipped FFF parts in wax before, mostly as like a cure to layer lines. But it's mostly used for art pieces, not so much for aerospace castings. But I don't see why some research couldn't be done to see if you can maybe dipping would make it more consistent and possibly improve surface finish that way. Did I answer your question?
IPS. Thank you.
Yeah. Any other questions before we break for the day? All right, it looks like we're good. If you have any more questions, feel free to email me. I'll be glad to answer them. Other than that, everyone, have a good rest of your day. Have a happy 4th of July. And good luck on the rest of your week.